Hello and welcome to C3STREAM Land. Today we are going to talk about algebraic tiles. If you have been following my videos since the beginning, you can see that in the last video we just saw how we can multiply two algebraic terms together using base 10 blocks. And I have also mentioned at the end of the video that base 10 blocks is not an effective way to multiply two algebraic expressions together. Why? Because it becomes very difficult to represent negative terms using base 10 blocks. Now let's see how algebraic tiles look like. I'm just going to draw base 10 blocks as well to draw the comparison between the two. As you can see, these are my base 10 blocks and these are my algebraic tiles. They look pretty similar. We are not going to consider the shape, whether it is smaller or bigger at this point, or thinner or thicker. We are just simply going to see three things. One, they both have similarities, but there are three significant differences. One significant difference is base 10 blocks have very finite values. For example, I can define each block as 1 and each rod as collection of 10 blocks. That's why if you can see closely, my rod has these lines or markings which shows me that if I put 10 blocks together, it forms a rod. Whereas in algebraic tiles, you can see there are no markings over here. That means it doesn't signify how many blocks I can put together to make this particular rod. So the value for my rod in algebraic tiles is unspecified. That's why I call it X. This value can be anything. Similarly, for the flat, as you can see, no markings. So even the value for my flat is unspecified. But I can multiply two rods together, as we saw in the last video. I can multiply two rods. X times X makes X squared, which is similar to multiplying two rods together in the base 10 blocks, which is 10 times 10 is 100. Now what happens this way is this gives us liberty to represent three kinds of terms, algebraic terms, using algebraic tiles. There are three. One is constant term, all the constant terms like 6, 7, 8, 9, -5, -4. All these terms can be represented using this block. All the linear terms, 4x, -7x, 5x, -10x, can be represented using the rod. And all the quadratic terms, 3x squared, -4x squared, or -4x squared, can be represented using the flat. Now, that's an interesting observation. But how do we represent negative terms? And which is the third and the most significant difference between the base 10 blocks and algebraic tiles. As you can see, base 10 blocks are all in same color. That means entire flat or rod or block, they have one color. But if I flip the algebraic tiles together, as you can see, algebraic tiles are represented with two colors on different sides, and this allows me to represent a positive or a negative term. If I have to say x squared, I can simply keep my flat like this. But if I have to say -x squared, I can simply flip it over and put it on the blue side, and that will make viewer understand that I'm talking about a negative term. And this really simplifies a lot of things. Now let's see in the next video how we can multiply two terms together using our algebraic tiles this time. Till then, happy exploring.